Good morning, this is your Stat Sensei, Mr. Spensei, and this is problems 81 through 90 of the death packet. All right, a soda manufacturer claims that its Cherry Fizz soda has more carbonation than the competitor's Cherry Eclipse soda. Bottles of both types of soda are open, covered with a balloon, and then shaken. The diameter of each balloon is then measured. The mean diameters are 2.3 inches for the Cherry Fizz and 2.1 inches for the Cherry Eclipse. A 90% confidence interval, but estimate the difference in mean diameters in inches gives us this negative zero point 0.8 to 1.2. Which of the following claims is supported by the interval? Because 2.3 inches is larger than 2.1, the manufacturer is correct. I can see why people would say that, but that's not what's supported by the interval. And the reason why is because zero is contained in the interval, which means it's possible that there's no difference. So our best answer choice is E. It's possible that there's no difference in mean carbonation because zero does lie within the interval. All right, moving on to the next one. Two ride-sharing companies, A and B, provide service for a certain city. A random sample of 52 trips made by company A and a random sample of 52 trips made by company B were selected. And the number of miles traveled for each trip was recorded. The difference between the sample means for the two companies, A minus B, was used to construct the 95% confidence interval and was turned out to be 1.86 to 2.15. And by the way, that should be a decimal, not a comma. Um, Which of the following is a correct interpretation of the interval? We are 95% confident that the true difference in sample means for miles traveled by the two companies is between 1.86 and 2.15 miles. That's really, really close, except we never talk about the sample means when we're talking about confidence intervals because we're 100% certain that it lies within, that the sample means lies within the interval because that's what we used. What we are estimating is the population mean, and that makes B right, which says we are 95% confident the difference in population means for miles traveled by the two companies is between 1.86 and 2.15 miles. All right, so 82 is B. All right, moving on to 83. First year high school students were randomly put into either traditional math classes or math classes taught with a new innovative approach. In a standard algebra test, 230 traditionally taught students scored an average of 76.5 with a standard deviation of 7.4, while 185 students under the new approach averaged 7.8 with a standard deviation of 5.6. Is there sufficient evidence of a difference in the test results? All right, so our formula for this is T equals x bar 1 minus x bar 2 over S1 squared, standard deviation of the first one squared in 1 plus S1 squared over in 2. And we just need to plug in. So obviously we're going to be 76.5 minus 7.8. And everything has to be under the standard deviation. And we had 230 in the traditional class, and we had 185 in the new class. Well, the formula that accomplishes what we're looking for question 83 or the plug-in is A. Now, some people are going, hey, what about this two times? We don't double the t-score. We would go two times the probability of t being something, but we don't double the t-score. Doubling the t-score is wrong, and that's what's wrong with this one. Okay? All right, 84. A sociologist studying the difference in ages between husbands and wives obtained a random sample of 55 married couples. All right, so we have 55 couples. The mean of the husband's age was 38.5 with a standard deviation of 12.6. The mean of the wife's ages was 36.9 with a standard deviation of 12.4. The sociologist calculated the difference between the ages for each couple. This is important because this tells me they're working with a paired. All right. And paired is T equals X bar D minus mu D over SD divided by the square root of N. So the mean difference was a 1.6 with a standard deviation of 2.1. A match paired hypothesis will be performed to investigate whether the difference is significant. And they tell us again that it's a match paired. All right. Which of the following is the standard error for the T statistic? Well, this is the formula, and the standard error is this part. So in this case, we're just looking for 2.1 divided by the square root of 55. Had this been not couples, had this not been a paired, had this been two groups, a group of married men compared to a group of women, married women, not married couples, then A would have been correct. But for this case, it's B because they ran a paired test. 85. The distribution of mass for United States pennies minted in 1982 is approximately normal with a mean of 2.5. Okay. A random sample of 10 pennies minted since 1982 was selected. Good thing it's normal because we have a small sample size. The sample had a mean mass of 2.4 and a standard deviation of 0.04. All right, so we have an X bar equal to 2.47, and we have an S equal to 0.04. The test statistics for the population has which of the following distributions? Well, it would be normal. All right. First off, this is just a z-score. All right. And our sample statistic would be normal if, in fact, we were not working with the standard deviation of the sample. And since we're working with the standard deviation of the sample, that makes it a t distribution. And the degrees of freedom for a t distribution are n minus 1. So 10 minus 1 is 9. Our best answer choice is D. All right, moving on to question 86. Two pain relief medicines are tested on random sample post-operative patients at the 5% level as to whether or not mean durations of relief are different. The data are given. What is the conclusion to the two sample t-test? Well, all right, first off, they didn't have to tell us the two sample t-test. It was nice of them to. The fact that the sample sizes were different let me know that it was a two sample t-test. So if I go to stat test and I drop down to two sample t-test, which is number 4, I can start inputting my data. My X1, my mean relief for the first one was 131, and my standard deviation from the sample is 12 with a sample size of 20. All right. At X2, we have 140 with a standard deviation of 15, and our sample size is also 15. All right. And they're looking for, are they different? So not equal would be correct, would be what we're looking for. All right. Now, one thing that they did not do was they did not tell us that the distribution of the means was the distribution was normal. They should have done that, but because that's not, we don't have to worry about that. They didn't state that as a conditional problem. We're going to continue on, but they should have told us that it was that they were normal because our sample sizes are less than 30. All right, so we have a not equal to situation. We don't pool. And I ended up getting a t statistic of 0.067. All right, so p is greater than 0.067. And they wanted us to test it at the 5% level. So 0.067 is greater than p. So our answer choice is D. We're going to fail to reject that null. All right. And here's the way that would have looked if we were going through things correctly. We'd go, all right, p value, alpha, 0.05, 0.067, 1. Make that 4 decimal places. This is greater. Decision is failed to reject. Remember, we only reject if the p-value is less. We like the large p-values. We like them, so we don't reject them. When they're small, we don't like them, so we reject them. 87. An experiment was conducted to determine whether the price of golf club affected the distance a golfer could hit a ball. A sample of 60 golfers was randomly assigned to one of two groups, C or E. The 30 golfers in Group C were given a club and told the price of the club was cheap. The 30 golfers in E were given the same club and told the price of the club was expensive. In reality, there was no difference in price. The golfers used their assigned clubs to hit a ball as far as they could. The distance in yards that each golfer hit the ball was recorded and the mean distance calculated for each group. A two sample T test for difference in means will be conducted. All right. Which of the following statements are true? Okay. So, and we're the data were collected using a random assignment. They said that they were randomly assigned, so we have to believe that they are. The data collected used a random selection. No, it wasn't randomly selected. Randomly selected means we put everyone in a hat and we drew, so they weren't randomly selected. The distribution of the difference in sample means will be approximately normal, yes, because our sample size is 30 or larger. So this is also true. So when we have 1 and 3, so our best answer choice for 87 is D. Moving on to 88. A civil engineer tested concrete samples to investigate the difference in strength in newtons per square millimeter between concrete hardened for 21 days and concrete hardened for 28 days. The engineer measured the strength from each sample, calculated the difference in the mean strength between the samples, and then constructed a 95% confidence interval, 2.9 to 3.1. So, in repeated samplings, here we're talking about in repeated sampling, which means if we do it over and over and over again, we expect to capture the true population mean 95% of the time. So we're looking for that. We expect to capture the true population mean. In repeated samples, the sample size, approximately 95% of the samples intervals constructed will capture the population difference in means. This is what we're looking for. Because in repeated sampling, we capture it 95% of the time. We don't like the first one. In repeated samplings of the sample, approximately 95 will yield the interval. No, we have no confidence in the interval. We're just saying that the interval will capture it. We don't have confidence in the endpoints. In repeated sampling, the sample size 95% will fall between this and this. No, it could be that we have something as crazy as what I call the goalpost, where everything was on the middle and everything was on the ends, and we're only estimating the difference. So the difference is in between, but not necessarily the actual value. So that's not possible, necessarily correct. In repeated samples, the sample size, approximately 95% of the intervals constructed from the samples will extend from 2.9 to 3.1. Again, we don't have confidence in those endpoints. All right, so our best answer choice for this one was D. We expect to capture it, which is our sentence stem. All right, 89. An ecologist has examined whether the number of fish caught in a large river basin has changed since a fire burned some of the surrounding forest area and vegetation along the river. Data in the form of fishing reports was available for a 5-year period before the fire from a random sample of 195 fishing reports before the fire. The mean catch was 6.3 with a standard deviation of 1.6. In a random sample of 143 reports 3 years after the fire, the mean catch was 7.1 with a standard deviation of 2.1. Which of the following represents the standard error of the difference in the mean number of fish caught? Well, our formula is T equals X bar 1 minus X bar 2 over S1 squared N1 plus S2 squared N2. So when we plug in, and this right here represents our standard error And so when we plug in, it should look just like this. And the one that does that is B. Okay. All right. Number 90. 10 students were randomly selected from a high school to take part in a program designed to raise their reading comprehension. Each student took a test before and after completing the program. The mean of the differences between the score after the program and before the program is 16. So we took um, the people were measured twice. If they're measured twice, this would make it paired. It was decided that all the students in the school would take part in this program. Ooh, that's interesting. Um, let MA note the mean score after the program and MB represents the score before. The 95% confidence interval estimate of the true mean difference is this. Which of the following statements is correct? Well, guess what? We did all of the students. And since we did all of the students, really not that likely that we need to actually do this. So really, I don't like the fact that it was all the students would take uh, uh, t- take part in the program, but um, the part that matters was the 10 randomly selected students. So because 10 randomly selected students, we're going, hey, we expect the difference between 9 and 23. And we're pretty likely that because we have a 95% confidence interval. And I misread that. Not all the students were sampled. If all the students were sampled, it would have been a census. We don't need to do it, but only 10 students were sampled. And because 10 were sampled, we have a sample size. We're going to use that to make an estimate for the population. And we say, hey, we're expecting that between 9 and 23-point differential to be quite likely, or 95% chance of having something along those lines. Okay? Or that the true difference in the will be somewhere between those values. All righty. Appreciate you watching and I hope to see you on the next one. Thank you.